So this is module 8 entitled Network Layer. In this module, we are to look into the characteristics of the network layer. We'll look into some details about IP version 4 and IP version 6. We'll look into concept of routing tables, how a host routes the packet, and an overview of the router's routing table. So again, the network layer is in between the data link and the transport. Uh, Very important component in the network layer is our IP address. So we've looked into IP address uh, in the previous chapter. IP address are being set in our end devices. Okay. The one that sets this is the administrator. So operating system should have this protocol, should have this IP address, and it is actually combined with TCP. So they are protocols suit TCP/IP. So this TCP/IP should be present in the operating system. Okay, and once our operating system has this, the administrator can set up an IP ad. These are these two, the TCP and this one, we're discussing, the IP ad, are very important components, both in a local area network and in a wide area network. Okay, uh, they are the ones responsible in providing end devices to exchange data. Their main role is to serve as an identifier. Just like us, we have address, right? The place we stay in has an address. And that serves as an identifier for the delivery boy to know where we are. Same thing here. That's the purpose of the IP address. There are two versions of the IP version 4, the one with the 4 dotted decimal. It's not scalable, especially now at this point. Uh, in time or in the condition of our internet infrastructure. So this is why they came up with IP version 6. Okay. So in this layer, network layer, during transmission, the data is being encapsulated. So uh, the meaning covered by IP address, and then during the receiver, encapsulation during sending. So during sending, again, data is being, sorry, not the data, but the segment, ano? The segment from the transport layer is being encapsulated in the network layer. So that's why the segment will now become a packet. It will be called as a packet. And then during the receiving part, receiving is the packet is to be de-encapsulated, meaning the IP address being removed and processed. Okay, during the transmission, sa example, Mapua Makati, this is Mapua Makati, this side here, this side here is Mapua Makati. A packet is to be forwarded to Mapua Intramuros, and there are routers between these two campuses. A router will perform routing. We'll have an overview of routing. So there's a router here, there's also a router here, and one task that the router will do is to perform routing. Routing, in analogy, is uh, the forward. In analogy, what we have in the routing is that it's like a Waze, right? It tells where to route the packet. It gives us direction. That's the purpose of the Waze. Okay. So, uh, in general, the data is being added with a couple of information in, and we call this as a header. Okay, a header. So in the transport, we call it as a segment header. In network layer, we call it as an IP header. Okay. Uh, so uh, once a packet is to be received, say again it is being received, the network layer component of our operating system examines the layer 3 address. Okay, there. So IP address does not change. Okay, during transmission, IP address does not change from source to destination. Okay, I will have an example of this in one of the chapters. There's this what we call as NAT, network address translation. NAT is usually set up in a router, and what it does is it translates a private IP to a public IP and vice versa. So there are a couple of terms that I mentioned. So for sure, uh, um, uh, it will not yet give you an idea of what NAT is, but as we go along in this course, we will tackle this NAT. We will have an overview of NAT in one of the chapters once we're done discussing the IP address. Because I mentioned about private and public IP, there's a separate chapter that covers that. And then in your Cisco 2, NAT is one chapter. It will be discussed in detail. It even includes the setup. You will set up NAT in a router. A characteristics of IP is connectionless, best effort, and media independent. What we mean by connectionless is it does not establish connection. This establishing a connection is a role of TCP. Okay, so this is why TCP is partnered with IP. Okay, so what we mean by establishing a connection is IP alone, IP address alone. It does not care if this mail is being received by the destination. Okay, it only cares of of having an identifier. So IP its role is just to have is to place an identifier, and that's the IP address here in the data. Okay. Uh, there. So there's no control information, synchronization acknowledgement. These terms are seen in TCP. Okay. So and then what I mentioned again, um, it has no notification. So IP alone, the sender will not know if the letter or the data has been received. Okay. So all of these informations here uh, are roles or function of the TCP. Okay? So to make it more reliable, IP is partnered with TCP. Okay? We will discuss TCP in one of the chapters. Another is, well, because it's connectionless, so IP is best effort. In Tagalog, gagawin ang lahat sa abot ng kanyang makakaya. That's best effort. He will do the best of his ability to send data going to the destination. Okay, it does not guarantee the delivery of the packet. The one that guarantees the delivery is again TCP. Okay, there's a reduced overhead. There's no acknowledgement. Okay, the one that has the acknowledgement is TCP, and it does not know if the other device is working or not. The one that knows that is TCP. Okay, and then media independent. Uh, the example you have wireless connection. Can IP work on that? Yes. Okay. IP, it does not care whether if you're using copper, twisted pair, coaxial, wireless, or fiber. Okay. For sure, IP will work on that. Okay. Um, IP is unreliable. Those items that were discussed here are roles of TCP. Okay, example, it does not have means to manage corrupt packets or cannot retransmit or cannot identify sequence of the packets. The one that does the sequencing of the packets, resending, and managing corruption of managing corrupted packets is TCP. And now let's look into IP version 4 packet. Again, during transmission, data is being encapsulated with added information, covered with added information. So in the network layer, uh, we are to tackle those added information. Again, we call it as packet. Okay. The purpose of those added information here in this layer, network layer, or the network header, is to ensure that the packet is sent to the correct direction, and that's because it has that identifier, the address. Okay, it contains information for network layer processing in various fields also. And the information in the header is used by layer 3 device like the router that handles the packet. That's very important concept, ha? That the router, which also falls on the network layer, whenever it processes the packet, it receives um, very important information that it looks into is the IP address. So I have here specific contents of the IP version 4 packet header. We have the version. Version indicates here if it's version 4 or version 6, and then the header length. And then we have here the QoS mechanism applied to this packet. Quality of service is discussed in Cisco 4. We have the total length, total capacity of the packet. Okay, that includes the header plus the data. Added informations are identification flag, fragment offset, and header checksum. Error detection, if you remember, that's the use of the checksum. Layer 4, it is indicated in the protocol. It is indicated here the layer 4 protocol. There's the time to leave set. Example 255 milliseconds. Okay. Um, the example, the time to leave is 255 milliseconds. So the packet should reach the destination before 255 milliseconds or to a device, say a router that can regenerate the signal. Okay. And then very important here in the packet is the IP ad, right? Source and destination IP address. So I have here the description of the different fields in the IP version header. So the main reason why they came up with IP version 6 is because uh, if we were to look into the internet infrastructure nowadays, they're running out of IP version 4. Take note that IP version 4 is ranging only from 0 to 255. With that, there are limited combinations. 4 billions roughly. Okay, uh, those are all that are the only combinations that the IP version 4 address has. And nowadays, it's not enough. So that's why they came up with IP version 6. IP version 6 has more. See, very that's ve- that's more. Oh, the more word is okay. So more combination. Okay, like around and undecillion. Okay, like IP version 4 only has billion, so there's trillion, no, gazillion. Not sure about the gazillion, ano, but undecillion. That's how many IP version 6 uh, has. Okay, um, there. Okay, that's the main reason why they came up with IP version 6. So as an overview of the IPv6 is, first it was developed by IATF. Another is, again as I mentioned, there are more space, there are more combinations that the IPv6 has, all because it has 128 bits. Okay, not like with IP version 4 which only has 32. It has improved the packet handling. There are the header, the added informations are simpler. Okay, few in IPv6 as compared to IP version 4. Another, there's no NAT in IPv6. Okay? The good thing with like this, with having no NAT in IPv6 is like this. Example like in Mapua Makati. Okay, Mapua Makati. Our computer in Mapua Makati, the laboratory computers we have there, what is set up there is a private IP. Okay, a private IP. And when we connect in the internet, we need to have a public IP. And with those 1,000 computers we have there in Mapua Makati, our public IP is limited. Say, example, let's say we only have, this is not the exact, ano, but let's say for those 1,000 computers, there's like, say, 200 public IPs. Okay? So we are to share public IPs. We need this public IP if we want to connect to Yahoo, to Google, to Cisco.net, Acad.com. Okay? So there's only a limited public IPs out there. So um, so the way it works is you need to uh, set up the NAT to translate the private to the assigned or shared public IP. Okay, that's for the IP version 4. You will have a much clearer picture of how it works again in the next chapter, next discussions. In IPv6, there's no NAT. Each computer in Mapua Makati has their own public IP. Okay? So that's much better. Imagine sample, let's say, in Mapua Makati, you have your own toilet, right? You have your own toilet. That's much better, right? That's much better because you don't need to fall in line. Okay, queuing is lessened with that kind of a setup. Okay, in IP version 4, public IP is being shared, like a shared public toilet. So everyone's using it, you need to fall in line. In IP version 6, each of the user or computer has their own public toilet or public IP v6 address. And in effect, it contributes on sending the packet faster. Okay. So here, I in my diagram here, there's only 4 billions of IP version 4 addresses in its combination, while in IPv6 there are around 340 undecillion combinations. So this is the specific header in IPv6. We have yung version, which indicates the version 6, traffic class, flow label, payload length, next header hop limit. Very important is the IPv6 address, source, and destination. I Okay, there. So next is all about overview of routing. Okay, all about this time all about routing. Okay, first thing to take note is the moment that say a PC1, example like in this diagram I have here, PC1 will send data. Okay, this say this one. Um, this packet is again always created here in PC1 on the source. Okay, and then PC1 will encapsulate this packet with like in this case in the network layer an IP address, source and destination IP address. And then, once it is encapsulated, what the operating system will do is it will check its own routing table. Each device has its own routing table. Okay. It is in the routing table. There's that very important word here, routing table. In this, it's like a table. Table is like not the table that where we eat, but a table like in Excel. So it has a list of addresses that it identify or recognize. Okay. So usually, let's say in that routing table, PC1 can identify those computers within the network. So for example, this is intended to PC2, okay? I just write 2. So it is intended to PC2. Okay, so um, it will check the routing table, its own routing table. It will identify that PC2 is on the same network, so it will be forwarded to the switch. Switch will forward that to PC2. Okay. Let's say the this time data is to be forwarded to a remote host. Okay, say R. Okay, R. If you notice, say there's a cloud here, meaning let's say for example, this is has something to do with internet. Internet. Okay. Uh, a local network like this one with the PC1 and PC2, those networks that are in the internet is unknown. Unknown. Again, unknown meaning hindi kilala. Unknown to this local network here, to this 192.168.10.0 network. Okay. Uh, Computers checking its routing table has a means to process that. And in the process, what it will do is, if it is unknown, okay, hindi kilala, what the computer will do is to forward it on the router. It will be forwarded to R1, and R1 will be the one to take charge in processing that unknown packet. That packet that is to be forwarded to this remote host. Okay? There. Another things to take note, uh, we have this IP ad 127001. Okay? It's a very special IP address. Um, Very na special pa. Anyways, it's we call as loopback. Loopback. Okay? The use of the loopback is it is used to test TCP/IP stack. Okay? I'll just write it by hand there. Loopback. So again, it's used to test TCP/IP stack. When you will be on your database, say you will explore PHP SQL, you'll work with forms, and then you have this SQL database localhost. So with the form connecting it to a database, um, so there are two components. There are two pages, two different pages. You want to connect the two of them. Your form, client side or front end, connecting to the database, back end. Uh, it uses TCP/IP component, and the IP address is that 127.0.0.1. Okay, loop back. Okay. Other terms, again, local host is destination is on the same LAN, and then remote host, if they are not on the same network, example like this remote host is on the internet, we call it as a remote host. I even had an example of this in the topology. And then the default gateway. Okay. Again, if you are to set up default gateway in our computer, okay, example this one, PC1, we've learned during our previous discussion that the default gateway of PC1 is the router to where this PC1 is connected. Specifically, the IP address of its LAN interface. Like example like this one. Say that is a G, let's say that is a G0/1 interface. Okay? So whatever IP addresses this G01 has, that is the default gateway of PC1. By concept, default gateway is unknown packets, unknown, okay? Those that are not known or unknown to PC1 are forwarded to the G01. Example, PC1. PC1 type yahoo.com, okay? Again, PC1, it type yahoo.com in the browser, Yahoo, say yahoo.com. There. Take note that Yahoo, it's not even an IP ad. And we mentioned before that the computer, what it process are in a form of an IP. So definitely, this request, this yahoo.com request to be forwarded to our network, it is unknown. Hindi kilala. Unknown to PC1. So what PC1 will do, uh, by default is to drop. It will be dropped, ignored, rejected, drop, unless there is a default gateway. If there is a default gateway set to PC1, what PC1 will do is to forward it to the default gateway. So router will receive this, router will receive that, and since router is the one connected to the internet, okay, diba yahoo.com is that's for the it needs to go to the internet infrastructure. So, router also has a setup to forward that to the internet. That's how it is. Okay. So again, um, PC1, you type Yahoo, that is unknown. Uh, so in a way, it will not be dropped. You need to set up default gateway to PC1. We've discussed that in chapter 2. And then, if there is a default gateway, it will be forwarded to the default gateway, which is the router. And router has a setup to forward that to the internet. That's how it is. I mentioned about a while ago about the that each end device has a routing table. Okay, a host routing table. The command for us to see the routing table in our end device is netstat -r. Okay, there. Example, very important parts here. So example, this one, no? The 000, this is, it points to the default gateway. This here, this part here, represents unknown packets. But in the previous slide, I mentioned that unknown packets, yahoo.com, google.com, it is to be forwarded to the default gateway. Okay, that's how it is. Also, we present in the routing table the loopback IP and then the local network. Okay, there. Um, there is a separate routing table for IPv6. Okay, so this one, the one that I just explained, it's a IP version for host routing table. And then routing. Again, routing, there is a setup for routing. It is discussed in detail in your Cisco 2. Okay, again, the moment that a packet received by a router, what the router will do, first thing the router will do is to uh, check the routing table. Okay? Check the routing table. It will examine the packet and check its routing table. It will search for the best match. What we mean by best match, it will check, example like this one. Um, so there is a destination IP of 10.1.1.10. So it will check for the best match. So who among this entry here that has the 10, that has a 10, for example, but this one, does the first number here has a 10? No. This one, no. This one has a 10. So this is the best match, right? For this destination IP. Okay? Um, in reality, that's not how it is. By concept is it looks into the destination network address of this IP ad. We will cover that term network address in the next chapter. So, but there, okay, this is the best match. So, what it will do, and it says in the routing table to forward it to R2. So what R1 will do is to forward it to R2 because that's what is stated in the routing table. That's how a router forwards packet or makes decisions in forwarding the packet. What we usually see in the routing table is uh, the status of the entry, the route entry. The possible status of the route entry may be directly connected, or remote, or default route. Okay. Um, Example, say let's look into R1. So R1 has this network 192.168.10, also 209.165.200.224, right? So R1, if you notice this network 192.168.10 and this 209, it is connected to R1, right? 192.168.10 is a network of its G0. This 209.165 is a network of this G01 interface of R1. So, if we classify the type of routes, these two network here are directly connected. Okay, they are directly connected. I have a network here of 10.120. Okay, it is not connected to R1. If R1 can see this remote network 10.1.2, it will be tagged as a remote. Okay, it's classified as a remote. In order for our R1 to see this remote network, you need to set up routing. If R2 is connected to the internet, right? There's a means for R1 to also be connected on the internet through R2. So there is an entry in its routing table that represents internet connection, and we call it as default route. Okay? But by definition, default route is it forwards traffic when there is not a match in the routing table. We usually see default route for internet, but not only for internet. There are other use of the default route. Not only it's not only about representing internet connection. You will explore on this routing table again a lot in module 2, Cisco 2. So there's in routing there's what we call a static route. Uh, Characteristic is you manually set it up on the router. What I mean by manually set it up, in static route you uh, the administrator, the company administrator needs to write the remote network in the routing table. Okay, that's what we mean by this configured manually. Um, this is applicable for a stub network, stub, or what we mean by stub is the a network or a connection or path that is single. If you have single path, example like in here, if you notice, R1 to R2, there's only one path, right? One connection. So best route to use is static route. Okay, that's what we mean by here by small redundant network. Okay, um, you in a topology in a real topology, you expect to see a combination of default dynamic route and a static route. There's another type of routing we call as dynamic routing. In dynamic routing, routers talk to each other. Best to use dynamic routing if you have alternative path. Like this one, R1 in connection to R2, there are two paths, right? This one, let's say 1, okay, path 1, and then this one, path 2. Okay? The good thing with dynamic routing is, example, this goes down, router will talk to each other, that say R1 will say, hey R3, you know what, my connection to R2 is down. RT will talk to R1, say, hey, don't worry, I am still connected to R2. If you are to send any packet to R2, send it to me. I will give it to R2. Okay? So, that's how dynamic routing is. Routers talk to each other. They send updates. Updates are routing information. Okay? Uh, and then they can discover remote network. Example, there's a new router here. Automatically, R2 will learn that there is a new router, a new network, or a new branch. Say, let's say this is R4. That's how it is. And then yun nga, and then another, if there is a path that goes down, router be able to routers will be able to identify that if there is a new path, or if there is a path that goes down. Okay, there is a detailed discussion on this in Cisco 2. So this slide here is just an overview. Expect that if you have routers, you explore on the routing table. The command for you to view the routing table is show IP route. Okay, we mentioned a while ago about directly connected network. It's represented by a C. A C means connected, directly connected. It always has a kapartner of L. Okay, so if you have a C, there's always an L. Example like this one, to yan, partner yan. This. Okay, so like, this is the routing table of R1. Example with R1, diba? R1 has a network in its G0 of 192.168.10.0. So that this is the entry. Okay? 192.168.10.0. A router, in order for a router to forward the packet, example, it has this packet that goes to, say, 10, example, that it goes to 10, 10, 10, 10 network. If you notice in the routing table, there's no 10, 10, 10, right? What the router will do is to drop it. Okay, that is its concept. It will drop the packet. But let's say it goes to 1012, 1012. So this packet goes to a 1012 network. And we have an entry for 1012. Uh, Wala din. There's no entry. So drop din yan. So let's say 1011. Mali ata yun. 1012 yung 1011 yung nandito. Anyways, so let's say it goes to 1011. 10, this is for 1011 network. 1011. And if you notice, there is a 1011 network here. So what R1 will do is to forward it to its G1, G01. Forward niya yan just sa G01. So R2 will receive that. R2 also has a routing table. It will see that they should be 1011. Okay? It will see that it is in map in this interface, forward niya doon. So this PC2 will receive that. That's how it works. There are other concepts behind this routing table. It will be discussed in Cisco 2. But for now, very important uh, for this slide that there's a routing table, that the command to check the routing table is show IP route, that there are different route sources that directly connected. And then if it is a remote, it is usually tagged with routing, dynamic routing protocol, or a static routing protocol. Static routing protocol, the source code is S. For dynamic routing, there are different dynamic routing protocols we have, like OSPF and EIGRP. Okay, so very important yung mga code here. Okay, and so I've reached the last part of this chapter. Keep safe. Together we learn as one.